Hello everyone, welcome to this session. We're going to talk about using R, an analytical tool, and a open source software for data analytics to automate IR works. So for those who don't know what is institutional research, IR, it is basically using social sciences research methodology to do research around education topics. It's usually held in a higher education institution, so that's called institutional research. I am a IR analyst at LaSalle University. I'd like to share some of my journey around how do I learn R and the ways I have been using it. So the first time I learned R was in a educational research course when I was completing my PhD in education at UCLA. I also had the opportunity to teach an undergrad student course about conducting social sciences research using R. After I was hired for my current position as an IR analyst, I find R is very useful for my day-to-day work in doing educational research. Today, I'm going to share with you my experience with using R. I'll first start with an overview of data analytics tools in the field of institutional research and educational research overall. Then I'll share how I have been using R for my work in educational research with specifically two examples. One is writing research reports with data visualizations. The second is preparing iPad survey, an annual survey collected by the US government. Lastly, I'll reflect on what I learned from the process and provide some learning resources for those who are interested in learning R. We will have a Q&A at the end of the presentation if you are attending virtually or in person. Please feel free to leave your questions if you are watching this recorded video. Let's get started. First of all, I'd like to know who is in the room to get a sense of all your background and experience around this topic. Can anyone who may identify themselves as a beginner in using R show me your hands? Feel free to leave a comment too via Zoom. Thanks for those who responded. No matter what are your background and experience with R, welcome to this session because I do think this session is suitable for all types of background and different levels of using R. Specifically, I hope this session can inspire those who are beginners, can inspire your curiosity towards learning R, and probably make a long-term plan to learn R and practice it. For those who already have some experience with R, I look forward to learning from you during the Q&A session about how you have been using R for your project. So R has been used in the field of institutional research quite a lot. I made that conclusion based on an analysis of the AIR Forum program book. AIR stands for Association of Institutional Research. It's the largest association for IR in the United States. So in this project, I want to know what are the data analytics tools and softwares that have been used for IR. I visualized the words mentioned in AIR Forum program book in the past decade. The program book listed usually the session titles and sometimes abstracts of the session are also included in the program book. In a later slide, I'll show you how I did the project in more detail. But on this slide, I just want to show you an overview of the trends of different data tools used by IR professionals as they are presenting in the past AIR forum sessions. And probably this could help us to reflect on how IR professionals are using different data tools. Let's see this graph in more detail. So from this graph, Excel and SPSS, as you can see in the black and gray lines, they are both popular before 2017, while since 2019, it seems they are no longer mentioned in the session titles or abstracts in the AIR Forum program guide. On the other hand, let's see, Python appeared at the first time, it seems, since 2017 in this program book, and has been increasingly mentioned during AIR Forum sessions in recent years. And let's look at R and SAS, which is the orange line and the yellow lines. They seem to be consistently very popular during the 10 years. R has already been mentioned and kept being mentioned in session titles and abstracts in recent years as well, especially since 2017. We can see a boom of sessions mentioning R. Okay, so that's kind of the whole picture, big picture of several selected data analytics tools. And I just want to show you the history and kind of to intuitively get a sense of how R has been used in the field of institutional research and kind of demonstrate that it has been popular. It has a lot of users, it seems, and people are talking about it consistently the whole decade. So after reviewing how the field might be using R, I'd like to also thank one of the inspirational person and her post on this topic. And I'll talk more about this topic in detail and share the codes in a later slide, as I promised. So on this slide, though, I also want to share a little bit of an overview of how I have been used R for IR project. Firstly, I find R is really helpful for data management, specifically file preparation and data file consistency checking. For example, I use R to prepare files to submit to the National Student Clearinghouse, following their specific formats and rules. So if you build a R script one time for a National Student Clearinghouse file, the next time you need it, you just run this file with an updated list of students. So the data management in that sense is just a file preparation tools. Another example is data freezing. So I always use R to manage different data files to compare one file, for example, from the registrar's office, and then compare that with a file from the system generated by our data warehouse. So I kind of matching the data files, finding what's not matched to ensure we can freeze our enrollment data accurately. So that's some example of how I use R to manage different files and prepare different files. And also clean and compare different files to ensure data consistency. The second area I've been using R is to fulfill those data requests. As we may all experience, if you are an educational researcher, especially in institutional research, there's a lot of data requests from our faculty members, our staff, and leadership teams, like provosts and vice presidents. Usually, they request data and reports about the institution's enrollment, student demography, and what's the grade of our course, like the distribution like. The other part also are the external reports and external data requests that most often IR professionals will do the surveys, for example, iPads and common data sets. A lot of them are on an annual basis and US ranking, of course. So both internal and external data requests, I have been using R quite a lot in the process of fulfilling those requests. The main reason is they are kind of repetitive, and you can use R to build one script one time this year, and next year you just reuse the script, because a lot of the times the survey questions and internal requests are similar. The last part I used R is for data visualization. I know a lot of people here might have been using subscribed softwares, data visualization tools like Tableau, Power BI, but I basically use R because it's free. It's an open source platform that offers me a lot of customization and also sometimes fancy functions. However, there is a steep learning curve, but once you master it, you can build scripts, you can save your own scripts, and then you reuse your script a lot of the times to build visualizations. Personally, I think it's not as complicated as it sounds. It's just the first time you're building it. That's when the learning curve happens. But I'm going to share with you the scripts I built to help those first timers to build your project scripts, and for you to maybe use some of my examples so that you don't need to build from scratch later, like in a later slide about learning resources. So for data visualization, I use R mostly for building static visualization, like bar charts, pie charts, and line graphs to present, for example, survey findings or other research findings that needs visualization. This is used most often at my institution because our internal data requests are mostly fulfilled by a PDF format report instead of sending people a website for more interactive format of reports. So I use R for building static visualization. But I do want to mention that our Shiny app is an option there. It's a more complex option, but it has much more functions of building interactive visualizations, maybe comparable to Tableau and Power BI. Another really useful way of using R is that you can build one script and apply different filters every time to build a totally different report. These reports are based on the same code, but reporting differently for example, different population or for different programs or different schools, depending on what filter you apply. So that would reduce a lot of repetition works in IR. There are other ways I have been using R, but to be honest, less frequently used compared with the first three aspects. I connected R with GitHub for version control. I also use R to scrape website. For example, I scraped the Air website for a list of sessions to see which one of my friends are presenting. I also used R to analyze, for example, the Air Forum Program Guide, which is kind of a qualitative textual analysis project that I will share more in a later slide. That's an overview of how I use R. Now I'm going to spend more time to walk you through some R code and talk about two examples. The first one is about visualization. So this graph, you've seen that before on a previous slide to review data analytics tools. In this slide, however, I provide much more detail. So one piece of code chunk here. I think this code chunk is the key to make this presentation of this visualization. Let me walk you through this code chunk. In the first line of code, I created a TPL like a pivot table in Excel to summarize counts and percentage of different words. So DTA, the data, is the name of the data file. So it has 2 columns and actually 0.7 billion rows, representing each word mentioned in the Air Forum Program Guide, and also the year the word was mentioned. The second line of code filtered specific word of interest for this visualization, and then the last line of code summarized these words in terms of their count per year and calculate percentages based on the count. The whole source code can be found here on my GitHub page. This project is inspired, again, by a colleague and her posts. But I kind of included more years in this project. So that's the example of visualization. But I also want to emphasize those comments as a kind of documentation process. So let's talk about more about documentation and using comments to explain the code. So this code chunk here is the code I used to create a data table for the Air Forum Program Guide project. This first line of code just saves the program guide file names as a list, so that in the for loop here, we can read the files one by one. Let's focus on what's happening within the for loop here. The first line in the for loop extracts any 4-digit group in the file name and save it as the year. Then we use a self-build function called text prepper to read the file. This function reads a PDF file and breaks all text in the file into single words per row. I'll show you details about this function soon. We end up getting 0.7 million rows, as I mentioned before. So each row is one word from the program guide, along with the year of the word appeared in which program guide. Now let's see what the text prepper function looks like. Since we want to look for single word in the PDF file, we need to define what a single word looks like, and we use a regular expression to do that, which is the first line in this code chunk I just displayed here. Then we're ready to define the function. please note that the function should be defined actually before the first code chunk box here, because like in other words, you should define a function before you use the function. So the text prepper function here is defined as taking f as input, which is a file name. Then the PDF text function is a function from the PDF tools library to read a PDF file. After the PDF text function, we will get many rows of text. Each row is one page of the PDF file. The next important line of code is this unmasked tokens function, which is a function in the tidy text library to break paragraphs or pages of text into units that you define. Here, we want the unit to be word using the red object we defined at the beginning. The whole function we defined will then return a data frame with one word per row. The whole process is somewhat complicated, as you may find, and this is where documentation is so helpful. You can see how comments are added for almost each line of code so that we can understand what's going on. After showing you the process of creating the data, let's see how we can use the same data to reproduce the visualization I showed you on the previous slide. So on this slide, I used the same data and applied a different filter to include words of Tableau, Power BI, and visualization this time. This is a visualization easily reproduced based on the same code with a different group of words about visualization this time. So last time is about data analytics tools. As you can see in this graph, visualization has been increasingly talked about in Air Forum, as shown in the black line. Tableau is very popular too, while Power BI has not been talked about much. To some, the Air Forum program side analysis project is an interesting one, I think. You can play with it to see different topics and how different words are mentioned in sessions in different years. Again, the source code can be found on my GitHub page, and this is inspired by a colleague, Ari Spergel. I have another brief code chunk to show you about preparing iPads report. In this code chunk, I am preparing numbers of enrollment of different racial groups based on student status. When what I am displaying here is a table created by R codes, and specifically this code chunk produces the number of returning students highlighted in the table. I used similar code just by replacing the values in the filter function to reproduce all the other columns in this table and all the other tables for different iPad survey questions. I do have another long R script I used to clean and prepare the enrollment data containing enrolled students of a whole academic year with different columns like gender, race, level, full-time, part-time status, distance education status, etc. So that whole data file I used to report iPads. Due to time limit, I cannot walk you through them, but I will share the code with you at the end of this presentation, providing you the link to the code. So that's my two examples. I'd like to spend some time to share my reflections on my experience of using R, and what I find about the opportunities of using R is, first of all, I use R a lot because of a few advantages it brings to my day-to-day IR work. It is very helpful to reduce repetitions in data reporting, especially those annual reports, and also frequent internal requests as well. If you find those requests very similar, like just for a different school or different year, you can really build one R project once and use it for a lot of different data requests. And then also R is very helpful for data visualizations and documentations. Because I don't have a very good memory, so I really need some place to take notes to remind myself what I did. So I find that probably for me, the most helpful part of using R is I can write comments about the steps I took to clean the data, which is really helpful for backtracing if there's an error in the data analysis at a later stage. It's also really helpful for me to sort out my logic of thinking. I took R as a data planning tool sometimes, as I can write my plan of data analysis and fill in codes to achieve them step by step. For example, when I get a somewhat complex data request, I'll open RStudio and kind of like journaling about my thinking about the request. And I'll write down the request, then I'll write down where do I find the data, what's the plan to request the data, and then what's the plan to analyze the data, stuff like that. So I really like the documentation process using R. Sometimes I also think R code itself are a version of documentation as well, especially when you have some like messy data that you need to clean. I think it's really helpful if you document the process of your data cleaning, because sometimes you might misunderstand some code or mistakenly use a filter during the data cleaning process. So if you write the code instead of using, for example, Excel, which you can only click, you don't even know what you did sometimes. So using R, it's easier to trace back to see what you did and where the mistakes might be. So you can fix the mistake there in your code and keep the rest correct codes. Instead of doing it all over again. R is also very helpful for teammates and others to refer your comments and refer your steps of cleaning the data to know what you have done. So in the documentation process and writing the code itself can be very helpful. And then you can, as I mentioned, the GitHub, like you can connect R with GitHub to trace different versions of your project. And also R is suitable for building data models, machine learning, all the fancy that stuff. Lastly, I don't have time to show you today, but using R is very convenient in the sense that you can complete a whole project in one place. What I mean is from data importing to cleaning the data, to analyzing the data and visualizing the data, and creating a report itself. You can do them all in one R Markdown using RStudio. You can write text just like you write text in a Word document and embed the output of your analyze within those texts. This PowerPoint presentation is actually made in R, and I can choose to only show the output, like the visualization, or also show the code that I use to make the presentation, to make the visualization. Sometimes if you really like to learn new things and you like to explore, especially for functions that's not currently available in a Word or PowerPoint. For example, like there is no timer function for PowerPoint within the PowerPoint software. I then Google how to add a timer in presentation using R. There's always some geek who created a package for that. So R has a really great community, and it's open source, so everyone can contribute. There's probably thousands of packages that's been already built there to achieve different kinds of functions and purposes. This also means that if you meet a problem or a challenge, if you cannot figure out some of your own code or how to fix it, there's like 99% of chance that there's someone else also met the problem before and get it solved from the R community. So people answer questions and build packages to achieve add demand function. I think I talked enough about the opportunities, and maybe everyone is excited about learning R, but I do want to know that it could be overwhelming and a steep learning curve. From my experience, though, if you do have some curiosity and you are patient to yourself, then you are able to find a way to practice and to learn. You will be okay. It's open source. There's a community there to support you. Be patient with yourself, especially at the beginning. There's a lot of frustrating time, I believe, when you cannot get code running or if you got a lot of error messages. I remember one time I'm taking a Coursera course for Python, and the instructor said, do not take the error messages as saying you got a mistake. Instead, it's just the computer is not understanding the code. You just need to find a way to communicate well with the computer, and that's it. Be patient with the computer. It's just trying to figure out how to speak with the computer. So don't be too frustrated when you get an error message. Another challenge that may apply to institutional research professional is how to communicate about data analysis process. Let's face it, our code can be complicated, especially for colleagues without any coding background. It can be overwhelming to read our code. So sometimes I find it's helpful to produce a copy of the data in Excel because the Excel version is much more user-friendly to share with other people. Also, I think it's a good habit to produce an Excel version of the data for yourself to double check if like using R and using Excel can produce the same results. They should be the same, but if not, that's an indication of something might be wrong in your code. So just to double check. Lastly, I'd like to share some resources that has been helpful for me to learn R. If you are a beginner in using R, I'd suggest you start with more user-friendly online courses. I find those helpful, like DataCamp and Coursera, I personally have used. There are a few books to read, but sometimes reading books to learn technical skills can be hard. So tutorials and workshops might be easier to see things in action. I will actually hold 2 workshops with Northeast Air this summer to dive deeper on some R scripts I built and used for IR projects or generally social sciences research. I will have 1.5 hours there to show step by step the process of how I build and how I use my scripts for iPads and other projects. There are also some blogs I subscribed that are good knowledge refreshers on data science generally, and other workshops and conferences you can attend to keep updated with R. Most of all, I guess, is to practice. If you have some free time or some professional development time, you may try to migrate your IR project from Excel to R. But if you're not having a previous IR project and don't know where to start, you can find some data projects, I believe, in Kaggle. So when you practice R, there are a few websites that will be very helpful when you have specific questions. You can search your question on Google, and most of the time, it will direct you to Stack Overflow or some other discussion forums. I find them really helpful. Thank you very much. Please contact me if you have any questions or if you want to connect, just want to talk more about institutional research with me, or talk about life in general. Welcome to send me an email. Let's open for questions.